Okay, moving on to number 8, we're going to graph a rational function. So we're going to graph a hyperbola, and let's see. There are certain things that we like to know and that we like to include on our graphs. So for each one, let's start with, we like to know if there is a simplified version of the function that we're working with. Now sometimes a function has to be factored and canceled and so on. In this case, the simplified version is the same as the one we see. That can't be simplified any further. We also like first to look for a whole. That is, anything that cancels out would lead us to having a hole in the graph or a discontinuity. In this case, there are none because we didn't get to cancel anything. The next thing that we might look for is a vertical asymptote. We find a vertical asymptote by setting our denominator equal to 0. In this case, that's x minus 5 equals 0 or x equals 5. At x equals 5, I'm going to put in a dashed vertical line, which is our vertical asymptote. Next, let's look for a horizontal asymptote. The horizontal asymptote is determined by looking at the power of the denominator versus the power of the numerator. In this case, we would be considered bottom heavy because the power of the denominator, 1, is greater than the power of the numerator, 0. There is no x in the numerator, notice. Therefore, our horizontal asymptote would be equal to y equals k. Notice there is no k in this problem. It's a 0. So our horizontal asymptote will be y equals 0. I'm going to draw in the horizontal asymptote as a dashed horizontal line at y equals 0. Next, we might look for an x-intercept. Our x-intercept, of course, occurs where y equals 0. This is true in all our graphs. Of course, our x-intercept is on the x-axis, and on the x-axis our y value is 0. So take the y in our equation, set it equal to 0, and let's solve. Notice that for our equation to equal 0, the numerator of that expression would also have to be equal to 0. And since 3 is a constant, it can never equal 0. Therefore, there is no x-intercept. Now let's look for a y-intercept. Of course, our y-intercept is on our y-axis, and therefore x is equal to 0. So let's go back to our original equation and plug in 0 for x. Wherever an x occurs, we know that term is going to drop out because it's equal to 0. And our y-intercept then is equal to negative 3/5. I'm going to go put that on the graph. The y-intercept occurs on the y-axis at negative 3/5. Okay, now that only gives us 1 point and 2 asymptotes. What we usually ask for are at least 2 points on each side of our vertical asymptote. After that, we'll just sketch. Notice that it pays to pick easy values to work with. On the left of my asymptote, I'm going to choose the values just because they're very easy to work with, 2 and 4. Actually, because I already have an intercept, I don't really need one of those points, but I'm going to put them both on it anyway. To the right of my asymptote, I'm going to choose 6 and 8. Notice why I choose these values, because they're very easy to work with. If you plug in 2 for x, you get 3 over negative 3, which is negative 1. If you plug in 4 for x, you get 4 minus 5 in the denominator, and 3 over negative 1 is negative 3. Plugging in 6, we get positive 3, and plugging in 8, we get positive 1. Let's go plot these points. 2, negative 1, 4, negative 3, 6, 3, and 8, 1. We now can sketch in our graph. Remember that our graph is a hyperbola. It has 2 branches that are on the diagonal of each other. Each of these branches has to go through the points that we've found and approach the asymptotes. Notice we do not cross the asymptotes. If it looks like your graph touches, that's okay, but never allow it to cross. We know it doesn't really touch, but sometimes it's hard to show that in the graph itself. Make sure that your graph looks like it's a reflection across the intersection of those 2 asymptotes, and that it's the same approximate shape and distance from that intersection. This one looks pretty good. While we're talking about this graph, let's talk about its domain and range. Remember, domain is the x values, and notice that these 2 branches cover all of the values from negative infinity all the way over to that asymptote at 5. It's open at 5 because it doesn't touch the asymptote, and then it starts again on the other side of the asymptote at 5 and goes to positive infinity. The range would be the y values. Of course, this graph starts at negative infinity. At the lowest, it goes all the way up to the asymptote at 0, does not touch 0, so we leave those brackets as open, and starts again at 0 and goes to infinity. There are other ways to write that, but this is probably the preferred for Honors Algebra 2.